So challenge number 4, PD levels. So whatever technology you're using, what is high PD, what is low PD? So the problem, I suppose, is when is high PD too high? When should I take action on my network? Online PD is uncalibrated. It's true, it's an uncalibrated measurement, online PD. There's no international standard for online PD application, and therefore there's no international standard for high PD. So on a particular piece of switchgear, there's no nice lookup table to say what is high PD. And if you locate PD, should you repair or monitor? You know, so you've got PD, you found where the PD is, then what? What should you do? So what's the mitigation steps? And this is quite a complex, lots of different images and diagrams. The first mitigation step, the very first thing you should do, which again, like links to the last slide, is you should have a very firm asset management process or combination of processes with simple stage gates. Your asset management process or managing your PD data, if you like, should be relatively simple. I mean, this is a 6-stage process that we've put up on here as an example. And 3 of those stages, so stage 2, stage 4, stage 6, is just an engineer assessing the data and making a decision. Essentially, they're the stage gates as well. Very simple process, does not need to be too complex, but you need very simple guidelines to know what you do at different stages. So regardless of what source of information you use to decide if something's low, medium, or high, decide if you move on to the next stage of location and maybe the next stage of repair, you need some sort of process written out and drawn out. So to help you with the stages and the decision making for online PD, typical PD levels exist. Okay, so for example, for switchgear PD, use a TEV sensor. There's an industry standard, and most PD companies follow the same. If it's less than 20 dB, it's low. If it's 20 to 30 dB, it's medium. And if it's 30 or above, or over 29, 30 or above, is high. That is a typical PD level. There's a couple of things you need to consider with that. Firstly, is that the relationship, and actually this is ultrasonic, not TEV, but it's the same. Firstly, is each network is different. Each substation is different. A particular medium level on one substation might concern you more than a high level on another substation. So you've got to consider not only the levels of PD, but then how that would impact your network should that asset fail. So we have many customers saying to us, when should we repair this cable? And the answer is, to a certain extent, depends how important the cable is. And so it might be, like I said before, it might be that you have typical sites in the central business districts or the urban areas that are more critical. And therefore, if you detect a lower PD, you take action sooner than you would if it was a high PD at a less priority site. If you're a production facility or a critical manufacturing plant, you may again take action much sooner. So that answers that, I suppose. A power utility is different to an industrial factory. What redundancy do you have? Do you have redundancy on your network? If there was a failure in a particular cable, is the network going to automatically reconfigure, or is there going to be a downtime of many hours that's going to cost production, or it's going to cost regulatory fines? Work with a PD company to set levels and guidelines. And the important thing is this, I think, monitor it and update it. So just because you have, you wrote out a process and you said, okay, we're going to say that if something's 30 dB, we're going to take action to repair the asset. Just because you've written that down doesn't mean you should follow that forever. Revert back, review, and assess. Is it working for us? Maybe on your network, you have lots of PD, and therefore it's too much resource to address every high PD. So maybe you need to shift your levels. Maybe on your network, you don't have much PD, and therefore you want to go lower. And then remember, some PD levels are measured in a logarithmic scale. So I put this chart on for this. So when it comes to particularly to switchgear PD, it's typically a logarithmic scale. So just be careful when it comes to the difference between 20 dB and 30 dB is very, very different to the difference between 30 dB and 40 dB. Roughly every 20 dB, you get an order of magnitude change in the PD level. So it's not just because something's 20 to 40, it's not, it's an order of magnitude change. So be very careful. And then importantly, trends are important. So looking at the PD trends and as they change over time is important as well. If you're using PD monitoring systems, we much more encourage following of PD trends and how they change compared to absolute magnitude, absolute level. And this diagram is actually quite nice to represent this. The magnitude is on the top. We can see that the magnitude remains quite consistent. the trend of PD count is changing. So trends are important if you've got the ability to trend. And indeed, with modern handheld equipment, you can trend data as well. Okay, next one, false positives. So the problem here is no PD equipment is perfect. Some is less advanced than others and can generate more false positives. So mitigation. Depending on your PD equipment, you may get false positives occurring. No PD equipment is perfect, but the main thing to do to mitigate this is understand the equipment you're using. What is the limitations of this equipment I'm using? So for example, I did mention that you should have PRPD in every equipment, but I understand in your network, you may have older handheld equipment. And some of the older handheld equipment just gave a level of TEV signal, low, medium, high, regardless of whether it was PD or background noise. It doesn't mean that that equipment is useless. That equipment can still be used in your network as long as you understand how it fits in your asset management tool. So how your stages operate. So for example, if I had many older TEV devices that only gave me a red light or green light, or only gave me a high warning of potential PD, but got interrupted with background noise, I would suggest that if there's a flag, you then go in with more advanced equipment. So I would make sure that you use that simple equipment, but then you install a stage of more advanced equipment to double check the measurements, double check the readings. So understand the data output, understand its limitations, understand the next steps. So just because you've found a high flag, if it could be a false positive, don't go to repair stage, go to verification stage, make sure what you've got is genuine, use more advanced equipment to verify PD. So carefully choose equipment. So if you're starting with a blank slate, carefully choose the equipment that fits with the capability of staff who will use it. So as well as considering the stages, there's no point in stage one buying the most advanced equipment on the market, the advanced handheld tools, the advanced equipment. If your technicians, if your engineers, if you don't have enough resource of technically competent engineers who have studied PD and who can allocate that certain amount of time to PD testing and PD measurement, because that might not be effective. Choose equipment that stores data as well. In this day and age with modern equipment, if you're starting with a blank plate, there's no excuse for not having PRPD based equipment. And to a certain extent, there's no excuse for not having equipment that stores data. You can, for a cost-effective level, you can have equipment and you can save data when you're doing your test. And that has a massive impact on how you manage this problem of false positives, because it means that the technicians in the field who may not focus on PD, who may do lots of different other jobs, they can just record the data. And because it's saved, you can have your condition monitoring team who do understand PD, they can verify the data and essentially reject these false positives. So making sure that your data is more accurate. And the cost difference between an equipment that doesn't store PD and that does store PD, the benefit of that cost difference is very quickly realized once you appreciate the time that you're saving, not having to send your condition monitoring engineers, which in many utilities is only a handful of people, not having to send your condition monitoring engineers to site 3 times a week. Instead, they can do everything from their office. Okay, number 6, expert resources. PD analysis and key decisions can require experience and expertise. And often this can be limited in an organization or non-existent if the technology is new to the organization, or maybe if the organization is small. I mean, we work with some very small networks, and so frankly, they don't have the resource to have a dedicated condition monitoring team, for example. This experience resource or expertise resource can be quite limited. Equally, even in some larger utilities, you might get staff doing 3 years in a condition monitoring team, then moving on, so you can get staff moving around as well. So what's the mitigation? The first one, asset management process. Again, and I cannot emphasize this enough, it simply comes down to putting a process on paper and saying, what resource do we need at different stages? Stage 1, we need some hardware. Stage 2, we need some expertise. Can we do that in-house? If so, what training do we need? Stage 3, we need some hardware. Stage 4, we need some expertise. Can we do that in-house, or do we need somebody else involved? Stage 5 is your location and repair. Again, do you need hardware and expertise, or do you use a third party? And again, stage 6 is the report and review at the end. And again, the same questions. As well as choosing the right tools for the job, you need to also consider who are the right people for the job. And I don't just mean people in your organization, I mean people outside of your organization. So is training required for people in your organization, or do you need to use third parties? And again, remember, you have thousands of assets, but when you get down to this level of location and repair and expert assessment, you will be doing this on less than 5% of your assets. So it's not guaranteed that it's not cost effective to use a third party. And we come across many customers who try to take too much in-house, and by doing so, they then lose the skill. Because IPEC turn up and we do an advanced training course for a number of days. If your condition monitoring team doesn't retain that knowledge, like I said, maybe they move on, maybe they change, maybe they've got different tasks to complete because they're a smaller company, then you need to make sure that you have a way of access to that knowledge. So maybe it's making a relationship with a third-party company, PD expert company, IPEC, for example, and keeping up to date like that. The only thing I'll say on this expert resource side, again, as I mentioned before, we have a thing in IPEC, it's free support. If you have a PD question, you can email IPEC, get in touch with IPEC, and we will help and assist. We're not here just to sell products. We're here to engage with clients, engage with asset managers, and help them with this process. So if you've got IPEC equipment and you're struggling with this process and you need assistance, you need help, maybe it's particularly with certain types of PD interpretation or whatever, please feel free to engage with us. And we're happy to look at how we can develop, look at how we can improve that process with you.